The iOmega Bernoulli Transportable. Who can forget this thing, right? Yeah, I'd never had one either. But I have one here. I've actually had this for many years now, just kind of sitting around. And I honestly don't even remember how it came to take ownership of this thing. But I have it. So we're going to look inside of it today. This device here was, I believe they were introduced in like the 80s sometime. This is actually an older model. I believe on the bottom it said 90, that this one was made in 92. So, I guess, yeah, somewhere in the 90s. This one here is the 150 megabyte version. There was some other ones that went up to like 230, 250 or something like that. And as a lot of you might remember, Omega also made like the zip drive and the Jazz and then the Click, which I guess never actually clicked. It was like a really short-lived product from what I remember. So this device here, it does work as far as I know. A long time ago I did hook it up to SCSI, as the interface in the back here kind of shows us. It is SCSI. And as some of you might remember, SCSI required terminators. I think this actually here might be some sort of a termination switch. Maybe it's got built-in termination. I don't remember exactly. We've got our power switch. You know, power comes in here. And right here we select the ID of the SCSI device on the bus there. And it's got a fan for blowing the heat out of it. Now, as the name suggests, Bernoulli Transportable obviously means that, or tells you that this device should be transportable. And sure enough, it is. This stand here on the bottom is not just a stand. If you pull this out, it actually becomes a carrying handle of sorts. Now, imagine how cool you would have looked walking down the street with your brand spanking new Bernoulli Transportable drive. Yeah, I can't imagine that you would have looked that cool. But anyways, it is transportable. And as I said, that also doubles as a stand there, so you can tuck this all the way in and it will sit flat just like that. Well, I would love to be able to demo this device here. Unfortunately, I'm really not going to be able to do so because of the fact that I have no discs for this, and also I'd have to cobble together a computer with a SCSI adapter, which I do have somewhere in all my stuff. So I could do that, but it's going to get us nowhere because I have no discs to even try it out with. Clint Bassinger of Lazy Game Reviews actually did do a video on one of these several years ago, which I'll link down below so you guys can see it if you are interested in watching one of these things in operation. That's about as much as I've been able to see about this particular thing. There's really not a ton of videos about this stuff that I've come across, so especially not any like doing a teardown or a showing of what's on the inside of one of these. So I figured that's at least something I can contribute or do, so that's what we're going to do here. So opening this thing up is really not that difficult. There's actually no screws on the bottom, as we can see. There were supposed to be some like little rubber mat pads in some of these corners, but we're missing all three but the one down here. Anyways, right here on the sides, we can see a couple of slots. These we can just push in, and the top here just kind of pops open like that, so it's fairly easy to open up this case. Apparently the one up here has not popped up yet. There it goes. Okay, so that's that side. As you can see, those tabs there just kind of hold the top cover on. This side here seems a little tough. The other side's coming up fairly easily, but there it goes. Okay, so this lifts up. There is the power supply. This is the top cover. As we can see, it's coated in some sort of metallic paint or something. I'm not sure if it's conductive or not. I'm assuming maybe it is, maybe for like EMI shielding and stuff. They've actually masked off the vents here with some tape, it looks like, and when they sprayed after that, they just removed it. Both sides are like that. And now this is what we have. This power supply is surprisingly big for what we have here. Let's get a better angle here so we can see what all we're looking at. So here we go. Hopefully that's a better top-down view there. Here we have the specs of the power supply, and let's zoom in on that. So we've got our standard just 5 and 12 volts at 1.5 amps, 1.5 amps from this huge thing for each one. But then again, it's a pretty old switching power supply. So it is pretty big. And as you can see right here, we got an output of 25.5 watts. So if we look back here at the interface portion of the drive, we can see that I have actually left all this stuff disconnected. So at some point when I opened this up last, which would have been like years ago, I mean, I have not touched this thing since the last time I messed with it or whatever. I left all this stuff unplugged apparently. But the drive itself is just a 5 1/4 inch drive. So, this is something that you would have actually been able to, like, say, taken out of this case and, like, put inside a PC, like, internally. Here is the spindle motor. And, we better not remove this rotor or the board or we're going to avoid all warranties. We wouldn't want to do that. Let's zoom in a bit on that here. So, this motor was apparently made by Samsung, as we can see there, and we've got this really old logo of theirs there. Down here in the corner is a small solenoid, and I believe this would have been to lock the disc in, keeping it from being able to be removed out of the front there. And then we've got a button here, which actually is not entirely a button at all. Let me show you what I mean. So that button on the top there, it's not like a self-enclosed button or anything. There's actually 2 pin terminals right there, and then they just have the little rubber thing that kind of shorts across them like that. So they just use that one of those like a little membrane button there with the carbon backing, and then they just have it touching those 2 pins to conduct across them. And then we've got 2 LEDs here. One I'm assuming would be for indicating that the disc is inserted, and then the other one for like when it's reading and writing. That would be like our ROM there, and it's called Oscar version 2.02. And then we've got a 6800 series micro there. That's a 60HHC16. So I'm guessing that's the one that's like doing all the controls and calculations and stuff for this thing. Got another little chip there that says NCR, no idea what that is. And down here on this end, looks like we've got a transistor here. Now actually this right here, this is an adjustable voltage regulator. It's an LM317. And then we've got some, what I'm assuming are either transistors or MOSFETs there. Probably maybe for voltage regulation or something. This chip over here looks like maybe it's the motor controller because it's like right in this area, and then we can see that there's 3 capacitors there, and then they go to this connector here, which would have been for the motor there. So yeah, so that would be our motor controller. And down here we have a sensor of sorts, which is probably a magnetic sensor, or maybe not, maybe it's light, because there's a black strip right there that kind of comes across it, and so that probably lets it know, like where the motor's like positioned. So that is the top section there. I'll probably end up removing this board just so we can see like what the heads look like and stuff. But this here should just come right up. I don't think there was any trick to this, or maybe there was. Actually, it looks like there might be a clip here on this side. This power supply should just come up, I believe. Alright, so it looks like I have to remove this screw from the back here real quick. Okay, that screw is out. Now this should just come right up. There is a... So there's a connector here that goes to the fan, comes directly from the power supply, and then there's another wire here that goes to this jack in the back here. Not entirely sure what that's for. I don't know if maybe this is like a remote turn on lead or something. This orange one that goes to here, because it's the only single thing going to this connector. So that's kind of odd. I really don't know what that was for. But so there's our power supply, and now this, yeah, this plastic thing right here. So it's got to kind of come up a bit, and it should release the drive. And there it goes. This thing is heavy. It's like super heavy for being as small as it is. But what makes it heavy, you can see we've got like some huge plates right there, some like metal plates, and you can see better than on the bottom. And we've got a warning there: do not remove plastic seals. So yeah, they really did not want you messing with this part of the drive. They're probably screw it up or something. We also have a warning here. It says warning: static sensitive electrical components. And then again on the bottom case here, we can see that they've coated this with something. This washer here, that was just kind of tucked in between the drive and the casing, so that, you know, there's really nothing holding it there. It's just kind of like being held on with the pressure from the drive itself. And then there's a plastic, or there's a metal clip here on the plastic that has a like a little spring tab there that kind of butts up against the case of the power supply. This construction here kind of reminds me of something that would be like a bridge or something, the side of a bridge. And then we've got our vehicles kind of going through there. Nothing else much back here. We've got our SCSI interface, and then we've got our Molex connector there for power. We've got some jumpers here that would be for like different options, and they are printed right here on the top. Although I'm not really entirely sure what they mean. Like that first one there says S, and then the next one says D, and then P. The P has a jumper on it, but like I said, I have no idea what any of these are. So right here where it says A2, A1, and A0, which are the next three, those would be our address. So I would be able to tell you that that's what that's for. And actually, yeah, these would have connected to the back through like this set of connectors here. So that would be one of them, and this would be the other one. This actually has a label here. I don't know if it actually tells what it's for. No, this one just has a just a name there, and then it says it has a date of November 1994. So I'm guessing that's about the time when this one was built. And also on the back here, we've got a ribbon cable. It's going down. That's probably going to be for the heads, and then the actuator for the heads, the one that like moves them back and forth. If we listen here, if I move this like back and forth, you might be able to hear something there going back and forth, and I'm pretty sure that's the heads. And at some point, it actually feels like there's like a rubber stop, like it kind of like bounces off, so it's not really like hitting anything hard there. So we've got a few screws to remove here. We got 1, 2, 3, 4, and 5, and I don't know if I have to do anything with the motor. I'm kind of hoping that the motor just comes up with this board when it lifts up. Undoing this ribbon cable here shouldn't be a big deal. We can actually pull the faceplate off. That one's fairly easy to do. This should just lift off. It's got a clip here. It's got a few on the bottom there. Another one on the other side. Okay, so that should allow this to come forward. And there it goes. So that's coming off. Oh, I forgot there's a little spring here for the door. There's 2 of them actually. Oh, actually no, there's 3. So we've got one spring here, one spring there, one spring there, and those are the ones that are holding this door shut. So I should remember to put those back where they go. But this is coming up, and there it is. And again, they've coated the inside of this, and there's our button that I was talking about. So that there just contacts those 2 pins. And then we've got a couple of little light pipes there for the LEDs. So what can we see from here? Well, not a terrible amount of stuff, but we can see the heads. As we can see, they're like kind of down there. So according to some of the stuff that I read about this, I guess when this thing is spinning, the air moving around the disc is supposed to like pull the heads closer or something like that. I'm not entirely sure, but right here up in the very front we can see that there's this sort of pin here, and that would be our solenoid for holding the disc in place. And actually, now that I think about it, that's probably why when I powered it up last time I didn't hear it do anything, because I could have sworn I remember it making some sort of click. And that's this thing right here. So that solenoid would pull this in to allow you to be able to put a disc in, and then it would lock it into place so it couldn't come out until you were done using it, you know, like and hit eject. Down here on the bottom, you've got this little tab here that I'm pretty sure it would be for like opening up the shutter that keeps the dust shield in place for the disc. our spindle motor is right up here at the top. We can see that if we turn the rotor up here, we can see the spindle turning, and it's got like a pin that comes down, and it's actually funky shaped. It's got like a triangle cutout right there in the middle. So I don't know exactly what the bottom of the disc would have looked like, but it's we can actually see that better. I'm hoping that once removing the board, maybe we'll be able to see what that rotor actually looks like from underneath. Alright, so I removed all the screws there, but the board is still not lifting up. So it does appear that the motor, at least like the armature and stuff, is probably attached to the casing here somehow. So it looks like I'm going to have to remove these 3 little screws, pull this rotor off, and then that should allow me to remove this board up. Alright, so there's all 3 of those little screws out. Now this should just lift right up. These magnets are actually quite strong, and oh, it's a ring magnet. It's all painted green, so I don't know what kind of material that is, but that's that. There is our armature here, and we've got 2 more screws there to remove, so that will probably allow the board to come up. Okay, that connector's out. Now this should hopefully just come right out. Oh, actually the whole thing's lifting up now. Looks like I didn't even need to remove those 2 screws. Oh well. But there comes the board, and the connector in the back already came out. So that's that side. Here is the opposite side. We can see that the solenoid is here, but the plunger still remains down here. So it's not like a completely enclosed solenoid assembly there. It's part of it's here, and then the rest is down here on the bottom. And then they've also got this foam stuff all along some of the portions here. We've got a kind of this copper strip here that's a little bit springy that went to that screw hole right there. So when you put the screw over the top, it looks like it grounds out this whole thing there. Then we've got this white plastic sheet that I don't know if I'll be able to remove easily. Looks like it's not completely attached, but I guess we'll find out. So on bottom of the board here, just a bunch of passive stuff. We've got a big copper trace there, like completely full of solder, and that would be the heat sinking for the motor driver there, so it probably does generate quite a bit of heat when it's running. Alright, so let's see what we can do here. Like I said, I don't know if this is going to lift up. I'm hoping it does. Feels like it's partially stuck down in some areas, or maybe just the edge of it kind of made it stick a little bit. Nope, there's definitely a sticky surface on the bottom. But I'll show you why it doesn't completely stick here in a sec. Hopefully if I can remove some of this stuff here without damaging anything. The foam is not glued down or anything, it's just kind of naturally tacky, so it's sticking to with all that pressure that's been on it, over the years. It's just kind of helping stick it down to the case there, but it is coming off if I'm gentle with it. Okay, so that's all the foam. These look like, well, this one here looks like it should just be able to fold up a bit. Like here's another, that would be like another grounding point most likely. I can just bend that upwards a bit. I should be able to continue prying this up. I don't know that we're actually going to be able to see much of the head assembly here either, but I guess we'll find out. Okay, this section here is really stuck down. So the whole reason why it wasn't so stuck down on this side over here was because they've got like all these like square like little cells here, and so this top layer was only sticking on where like the ridges of these are. So we can see that there's some lines there. So this looks like it's almost looks like it's got a copper coating on the bottom there, also for shielding most likely. This portion of the air, this plastic piece here, I don't know, maybe if I heat it up a little bit, might be able to get it to loosen up some. So we're just going to gently heat it up there, and I'll see if I can get it to unstick. Yeah, so unfortunately removing this top layer is really not going to reveal much, because all we have down here is like these big metal assemblies. But what we can see right here through this crack is the windings for that actuator, As you can see, it kind of moves back and forth there. So what this would be is they've got these windings like kind of going, you know, like around here, like in a rectangular, and then there's going to be like another element kind of in the middle, maybe the magnet itself. So that winding there kind of propels the heads like back and forth. And that's actually, now that I think about it, that may be what these are for there. These are probably for controlling the heads, because he's got some pretty beefy traces on them. I thought maybe, you know, there'd be some regulators, but we got two pretty large traces coming to here, and then these come off into this section. So yeah, that's pretty much most likely what these are. These are the actual controls for the head. So it's working kind of like in an H-bridge configuration there too. You know, like switch the polarity like positive and negative, and, you know, kind of in between, just adjust the voltage. So that way that, you know, kind of positions the head where it needs to go. Yeah, I don't really want to destroy this thing completely either, in case I ever have a chance to come across like some discs or whatever, so I can test it out. And I'm kind of hoping that I didn't do too much damage already as is. So this plastic, or this covering layer here, I'm just going to stick back down. There's really no point in taking it off, since I'm not going to be taking the whole head assembly apart. But I didn't want anybody left high and dry there trying to guess as to how the head assembly works. Basically, what it is, it's in this case, it looks like we've got two voice coils on each side, and then we probably have a magnet somewhere in the middle, or somewhere in that assembly there's magnets. So what it is these coils would have a certain polarity on them, and that would allow it to just kind of like go in and out, move the heads in and out. This whole assembly here would be mounted on some linear bearings of some sort. And basically that's how this whole thing works. We have the ribbon cable coming out the back there, and that would go to the heads and to the coils. So as the magnetic field around these coils like changes, then the heads move in and out, and that's how the control circuitry basically positions them. One thing I hadn't really noticed here or mentioned is that it's got the label here with all the information about this drive, and it says it's a 2 amp max on both the 5 and the 12 volt. And as we saw, the power supply there was rated up to 1.5 on each one. So I don't know if they were just kind of like hoping that power supply would not crap out, or, you know, if this is just like, you know, for like fractions of a second or whatever. But as I mentioned, this did power up the very last time I remember messing with it. Right here we have our model. It's a Beta 150A, and serial number, if that means anything. Yeah, there was really nothing on the other side except for see cautions. Well, here's something interesting that I just noticed. If we look inside that hole there, and we kind of nudge this to move the heads along, we see that there's these lines that start showing up there, and then as it progresses along, the darker lines get thicker and thicker. It's kind of hard to see there, but they are getting, dark lines are getting thicker until the point where it just goes completely black. And what I noticed is that on the opposite side of the board here is this little sensor assembly. It's a little optical sensor assembly. So one of the sides would be like an infrared LED or whatever, and then the other one would be maybe like a phototransistor or a photodiode or something. I thought it was just like a plastic pin to align things, but it's not. It is a sensor. And on the other side here, we can see that there's 4 contacts going down to that. So it looks like that there is for reading the position of the head assembly there. So that's how it keeps track of where it's at. That's pretty interesting, I thought. And that other sensor on the motor here, it is an optical assembly as well. You can see it's got the 2 little windows right there. On the very front of the board here, we do have another optical assembly. So that's probably for detecting something on a disc, like maybe read-write protection or something. And then there's also this other sensor here, and that goes down to where the assembly for the plunger there is to lock the disc in, and it's got this little tab right there on the side. So that would be the one that would, you know, interrupt light to this thing. I have it upside down here, but, you know, it would be like something like this, just to indicate when it's not locked. And, you know, when it's locked, it kind of, you can see that when it's extended outwards, it blocks the light flow, but when it goes down, it opens up that little slot there. So that's what that would be doing. A few more little things of interest on this board here. This here's an Adaptec chip, and I'm pretty sure that's probably the SCSI interface. We can see that it kind of has some traces going here to what's RAM. This one here looks like it's an SRAM, and then we've got a couple of DRAMs up here. So those are probably like buffer for the data that's going to be going in and out. I'm guessing. I'm not 100% sure here. And then this must be like maybe some work RAM or something. Here's the solenoid that we saw. It says 12 volt DC int, so I'm guessing intermittent duty there. And we can see that one of the traces here goes like pretty much directly to this transistor. So it looks like this transistor is the one driving that solenoid. Over here in between the stator of the brushless EC motor there, we can see we've got 3 Hall effect sensors. So those would be for positioning. And the assembly here is not like bolted to the board in any sort of way. It looks like they've just used some double-sided foam there. I don't want to peel it off, but you can see it. It's right there underneath the plastic piece. And I originally thought that I had to remove those 2 screws to be able to get this whole board to lift out from the other assembly, but no, this is actually mounted directly on the board there. So those screws are just holding the coil assembly itself to that plastic mount. Also up here in the front are those 2 pins that are actually the eject button. As we can see right there, they've bent these up, so that's looks like they've done a little bit of custom work there on those pins. Right in the middle of the board here we have a upside down. This is it's like a 32 megahertz oscillator, and looks like maybe that might be for this little microcontroller here. Some of the smaller stuff that we see around here, got a LSA. It looks like it's just a bunch of 7400 series logic here. 7406, we got 7406 right there. This one right here is actually an LM339, so that'd be like a quad comparator. Not sure what that would be right there. 358, so we've got like maybe, I think that's an op amp. Not entirely sure what this one here is. It's a UC5602 QP, maybe some sort of a buffer drive or something, because it goes like right to the interface here. So I'm thinking that's probably what that is. It's probably like a line driver. These 2 resistors here mounted on that socket, maybe that's for like some sort of option or something. It says bank 0, so yeah, who knows what the heck that's doing there. This resistor right here, right in between the drivers for the coil on the heads there, I'm pretty sure that's probably for like current sensing or something. And then this IC right here, which says 32H569-CL, maybe has something to do with the driving the coil. Not entirely sure. I'd probably have to look that up. Then this NCR chip right there, not entirely sure. It says Oscar Omega, so that's like probably some custom part there for the control of the drive, I'm guessing. A quick thing about the front of this faceplate here. This piece right here, this vent where it says Omega 150 multi-disc, this is actually removable. If I push on this clip here on the back, this whole piece comes off. So I'm guessing that was to make it easy to, be able to replace this, to identify what kind of drive you had, since as I mentioned, there was several different versions of this, some that were lower than 150, some that were above. So just replacing this, they wouldn't have to make like a whole new faceplate with like a new print right there. They could just replace this piece to denote what drive it was. And also this little flap right here, I thought that it may have been mounted like on sort of like hinges or something, and which is what I thought this stuff down here was. And if it would focus, that would be nice. There we go. So these springs, while they do provide some pressure to hold it shut, they don't have anything to do with like supporting this. And one of the springs fell off right here. It's right here, so I got to make sure I don't lose that. But anyway, so let's focus. Come on. So the way this is mounted is actually the plastic here bends. So yeah, it's flexible all right, but I'm just wondering if anybody ever actually had one of these break on them, from extended use, from like bending so much, because this thing would have had to bend like pretty much like all the way down to allow the whole cartridge to be inserted. So from that plastic constantly bending, I'm wondering how long this would have been expected to last. Well then, since we can't go much farther here without the risk of potentially destroying something beyond repair, I think the best thing to do would be for me to just put this back together and plug in power and see if it still does anything. As I mentioned earlier, I want to eventually see about maybe getting a disc or two and testing this out and see if it still works. There's some little grooves down here that those springs fit into. Something's not quite right here. This didn't go on right. Okay. There we go. Okay, I just realized this ring terminal that was here, that was just kind of tucked in there, was not like that from factory. At some point I removed the screw that it went to right there on the side of the case, so that was my bad. That's not how it was. So trying to find the screw for that, yeah, good luck, right? Years ago that I took that off, not gonna find it. So, but I did find one that fits in reasonably okay, so I'll just use that. All right, now that's properly grounded. Oh, and I was wrong up here about this like spring terminal like butting up against the case. It really doesn't, it just kind of sits there. So this is the only one here that I don't remember exactly where it connects to. I think it might be the one here that says, there's one that says TC, that's like right below the ID select on the header here. So I think it's that, but I'm not sure. I'm just gonna leave it off for now because like, it's not even gonna make a difference right now. I can't really do anything with this other than test to see if it powers up or not. So now that it's pretty much back together, and let's see if it does anything. The one thing I do remember it doing is I believe it used to blink here when it was plugged in and powered up. So I've got it plugged in now and I'm applying power, and here we go. Let's see what it does. There it goes. So looks like it's doing something. The solenoid here did click, and I don't know if the pin went up or not. Yeah, actually the pin did go up. Huh. And we saw that the spindle motor there tried to spin. I don't think hitting this button's going to do anything. Oh, it does. It flashes. I'm guessing that means that there's no disc. Let's see what happens if I interrupt that photo sensor up here, or put my finger in there. Nothing. I wonder if maybe it needs something reflective. Let's see. Take a little piece of this here. No. See if maybe some white paper will do it. Nope. Yeah, I don't know what triggers this thing to let it know that there's a disc inside or not. Yeah, I have no idea. Maybe there was something on the disc that was special to let it know that there was, you know, a disc in the drive. As it sits, I can't get it to do anything. Wait a minute, hold the phone. I think I figured it out. Turns out that if I rotate this while it's powered up, it goes through its check there to see if there's a disc. So I guess when you would put a disc in, it would bump the spindle there and cause it to go into a disc check mode. And if it can't find anything, then that's when it just kind of gives up. So yeah. And then since the solenoid there is powered up, once we disconnect power there, then it releases the plunger. Aha, I was wondering what it was doing here, but check this out. When we move it out of the way there, it goes back to seeking that black spot on the rotor. So I guess that's where it knows what position the spindle's in, which actually, now that I realize this, so basically when we saw that the bottom of the spindle there kind of had that funky shape, that must mean that this needs to be in a certain orientation on that spindle so that when you stick the disc in, it lets it know that it's been inserted. So I just kind of put this in at random, which is probably wrong. So I guess I'm going to have to figure out the correct orientation for this. Unfortunately, without an actual disc, I don't know exactly how I'm going to do that. All I basically can do at this point is kind of just take a guess. But I'm guessing maybe the triangle part would be like facing towards like the outside like that, so that when the disc comes in, maybe that's where it bumps it and it makes this rotate and then it repositions it. That's just my guess. So there we are. That was a look inside of one of these Bernoulli Transportable 150 multi-disc, and I hope that was kind of interesting if you were ever wondering what was inside of one of these things. Thank you all for watching, and I'll see you guys around the bench.